while you work on it, thanks for everyone for coming. If you haven't signed in yet, please sign in, and then there's pizza. So have at it. There should be 2 meat and 2 veg pizzas, so have at it. But yeah, thanks for coming. I see some new faces. Always excited. First, let's go around and introduce ourselves so we know who's here. My name is Catherine Ball. I'm a master's student in School for Future of Innovation and Society. Do citizen science stuff and coordinating the network this year for this academic year. And doing a bunch of other stuff. So,
I'm Jean Chitange. I'm staff at the School for Future of Innovation and Society. I work with Dan on a citizen science project where we're looking at libraries themselves for citizen science. So we're developing kits. If you were here last time, I think, or maybe 2 times ago, we showcased the kits that we create for patrons to check out the library.
So I'm Benjamin, and I'm a chemical engineering student here at ASU, and student work on the space.
My name is Shaha. I work in makerspace in my life. Hey, I'm Sushil, and I'm a PhD student in sustainability. Yeah, I've been here a few times. So I just say that today I have to leave early, so I might talk about it.
I'm Gage. I'm a first-year undergrad at Berkeley Honors College. I'm studying global health and neuroscience, and I'm just really looking forward to starting to branch out across the disciplines.
cool. You're in the right place.
My name is Victor Obeng. I am here. I'm running the MKRServices at the Library, and
Sam Giles. I also work at the library, and I've kind of got brought into the citizen science work through Dan. I've been helping him out with his citizen science and hubs project for public libraries. I've been attending these meetings for the last few months and been enjoying it. So glad to be here again.
I'm not going to get on camera. But I'm Dan Stanton. I'm a librarian here at Arizona State University and co-PI on the Libraries as Citizen Science Hubs project, which we have all the kits and signs delivered, and so we are awaiting information on how that's going in terms of kits being checked out and used, so that's very exciting. And then we'll be working towards phase 2 in the spring, and then also gearing up for a large events for Citizen Science Day on April 13th of 2019. So stay tuned.
Cool. All right, so the rest of this, if you've been to multiple meetings this semester, you'll have seen all this, but I'm going to quickly run down what the network is for you since this is your first meeting, so you have an idea. Basically comes down to citizen science is super cool. You can do all sorts of things. You can empower communities. You can assist researchers. And we have a lot of faculty and staff here at ASU who do citizen science that for a while didn't really know what each other was doing. And therefore, Darlene Cavalier kind of started this network as a way to connect people. And that's really the goal, is to kind of establish ASU as a university that is known for doing citizen science and related things. And as I said, we really weren't connected, so it was really hard to help support each other and share resources and knowledge about doing certain types of projects. So really, we just kind of exist to facilitate sharing knowledge, make it so projects are more visible. We're working on a website that will eventually showcase people's projects. It's the bottom of my priority list for the network so far, but so we're promoting things within the network through these meetings, through our listserv. We now have multiple social media, so we have a Facebook, we have a Twitter. We're working on recording our meetings and sharing them on a YouTube channel so that people can listen to everyone's presentations. So we're just working on figuring out how to best share all the resources that ASU has to offer. So just a rundown of some announcements. I made and have been passing around a survey for the Citizen Science Network of what projects people are currently working on, what kind of projects they are interested in. what sort of things they would like the network to help support them in, whether that's grant opportunities, just connecting with other people when applying for grants, things like that. I've only had 2 people respond, so could you please respond, because this is how the network is going to be more beneficial to everyone involved, is by getting feedback. So I would love feedback. Please fill it out. 2 kind of job opportunities. If anyone knows PhD students who are graduating, have recently graduated, North Carolina State has a citizen science postdoc opportunity posted right now that they're hiring for. And then the Citizen Science Association is hiring a community engagement specialist. So more information about both of those will be going out in the summary email after this meeting. Please pass them around, share it. And then we had someone who wasn't able to attend today, and I'm doing this so I get all of the details right. Center for Global Health is launching at ASU, the ASU sector, and their annual theme this year is Citizen Science and Global Health. So on November 26th from 11:30 to 1, they're having a series of talks about citizen science and its relation to global health. So if you're interested in that space, they would love for people to attend and really connect that initiative with the Citizen Science Network. So other than that, are there any announcements from any members about things that are happening?
One announcement is we're in the process of starting an undergraduate citizen science club.
Oh yeah.
So Gage, if you're interested in that, I don't have a business card on me, but I can give you one of those. But since it's kind of late in the semester, it may not kind of get going until the spring. But
I'm presuming Austin reached out to you.
Yeah.
Okay.
We've been talking about
cool,
that.
'cause I haven't had it.
There's a meeting this afternoon about how to start a student group, but they said we didn't have to attend that at this point. So that's something that's coming up, and we're hoping that will be something that, can work with this group, but also maybe when we have events or things going on at our partner libraries for this other grant, that might be something that people can show up and volunteer and help out at. So stay tuned for that.
I know you just came in, but we're doing general announcements, and
Yeah. Hi, I'm Julian Leach, and I work in the Libaries. I work with the director on several different initiatives. One of them from today being an engagement philosophy and practice initiative. So what we're starting to do is to build out basically a learning community around engagement and to rethink and challenge our traditional top-down approaches to engagement in sustainability and related fields. So it kind of really spans the gamut. But I'm starting in schools, so that's why the original focus. But what we've been doing is starting to kind of bring together different groups of people, organizations, and anybody who's individually interested in this particular work. Communities and really start to question some of our traditional approaches and to also explore different opportunities for capacity around humble and ethical engagement approaches, challenging the norm. And so we have a couple things that we've been offering as a highlight this semester, and we'll be relaunching in the spring, which is a graduate level course called Rethinking Community Engagement. There's a longer piece of that, but essentially that course is one of the mechanisms we're using around this idea of capacity building. It's one thing that's open to all graduate students of all students. We're also starting to, we just had our first event, but we're going to be having several more around like different things, skills building and knowledge sharing around these topics. We've addressed all the things we use around engagement, of course, and starting to more broadly within these programs. But we welcome all the input. So some examples have been ethics of global engagement, which was our panel that we just had. We have an event coming up actually in weeks that Dr. Cynthia Celine and the Generation Society is coordinating with one of her graduate students. And it's a workshop around engaging past, present, future. So it's really interesting, hands-on interactive session that's open to everybody. I'm going to pass along the announcement flyer. There's some
Yeah, I'll put that in our summary.
And I'll also pass along the flyer and information if anybody's interested. But we're kind of just getting started, so this is the very beginning stage of it. But the idea is that this is going to be a university-wide initiative, not just staying in silos that we tend to do with a lot of different initiatives around campus. But we really want to open it up to the broader network and really begin these kinds of ongoing dialogues around these resources. We do a lot of engagement for ASU, locally and globally, and not so great at really step back and reflecting on why we do what we do, how we do it, and the kind of unintended consequences of our impact, and also what we do in our presence, how that affects the communities. So trying to be more of a global partnership too. So it's not just in the future, it's not just going to be focused on like the internal ASU community, but really trying to welcome different community partners as co-learners in this process, and teachers to us because they're the ones with knowledge base that we should learn from. So kind of quick synopsis of what it's all about, but we welcome any input, and happy to stay a little bit longer afterwards to get my content info. But I'll pass
I'll make sure that it's giving you a good description. I'll include it in our thing. So anything else? Because Juliana told me she wanted to make sure she said that. So any other announcements before we get to speakers today? All right, cool. So today we have.
Hi, this is Darlene.
Wait, Darlene calling in.
Hey, Darlene.
Yes, hi. Sorry about that. Nice to talk to you all.
Hello. Oh, we were just wrapping up introductions and announcements. So do you want to introduce yourself real quick?
Sure. Hi, everybody. I'm calling in from Philadelphia, Pennsylvania, and I'm Darlene Cavalier. I'm part of the School for the Future of Innovation and Society, and I run SciStarter, which is a website that helps people find citizen science projects, like some of the ones that you're working on.
Great. Thanks, Darlene. So we'll get into our presenters now. And first up, we have Benjamin, who, I don't know, I was really excited about this because I got into citizen science through the Maker movement. So
Yeah. Hello.
We're going to talk about what we're going to talk about.
Hello. So my name is Benjamin, and once again, I'm a mechanical engineering student, grad student, and student work at the Makerspace here in Hayden Library. And I'm going to talk a little bit about what the Makerspace does. And so the Makerspace is, I would say, is a maker's heaven, where we have students, faculty, staff coming in to make cool stuff. So we have different equipment in there. We have 3D printers, we have vinyl cutters, we have button makers, we have book scanners, we have sewing area where you could sew, we have materials that you use. And the amazing thing is that all these resources are free. We also have AR and VR kits that Oculus Rifts and Oculus Go that we rent out to students for free. And it's an amazing place. You can come make stuff, create stuff. And my specialty is in CAD design, CAD modeling, and 3D printing. So I'm going to talk a bit about 3D printing. I'm a little bit biased with 3D printing. Maybe Shaha will continue with the other sections of the Makerspace. But how many of us have heard about 3D printing? Amazing, yeah. So I don't have to talk much, and we're done. So basically, 3D printing is a process of manufacturing. Mostly, it's used to make prototypes. But looking at the trend currently, there's a high possibility that it will really jump into actual production really soon. And actually, you have companies like GE making part of the engines or turbines with actually 3D printed materials. Yeah, so it's a really an amazing technology that it's really getting into. Currently, you also have even houses being 3D printed, so buildings being 3D printed. So there's a company who is working over in Ecuador, building houses to replace slum areas over in Ecuador. So basic explanation of what 3D printing is. So it's a method of manufacturing where usually have these layers being built, forming an actual model. So you start by designing your model, whatever you want to create, then we design it using CAD softwares. CAD softwares ranging from basic as Tinkercad to as complex as, there might be other complex CAD software, but we have SolidWorks, we have Fusion 360, we have 3D Max, 3ds Max. We have lots of CAD softwares that you could use. And so after making these models, what you do is that you export it into a language that the 3D printers understand. And it's kind of like, I'm from Ghana, originally from Ghana. And so say you come over to Ghana and you want to have a building, right? You go and see people who can speak English, right? So you have to get a translator to help you do that, right? So that what you do is that you have to export the CAD language to a language that the 3D understand. So you need a slicing software, and that slicing software is kind of like a translator, right? That translates it into the language that the 3D printers understand, right? So what it does is that it slices the model, the CAD model that you have, into different layers, and in there you input the settings that you want, how thick you want it to be, how fast you want it to print, and all those kind of stuff. So over at the Makerspace, we have different types of printers, but all of them are one form of 3D printers, which are the FDM printers. So the FDM printers, what they do is that they make models by melting plastic, mostly plastics, forming layers. So we all know 2D printing, which is printing out of a sheet of paper, printed on a sheet of paper. So the difference between that and FDM printers is that the 3D FDM printers add the Z-axis, right? So they build layer by layer, whatever you want to print. So I'll jump over to some cool projects that I'm working on. And one of the projects that I'm working on is on my thesis is I'm making a brick, a thermogalvanic brick, that's what I call it. And it uses the principle of thermodynamics to generate electricity. So in a place like Arizona, where outside is really hot, and during the summer, and inside is relatively cooler, you could, science has proven that you could use that temperature difference, you could convert that temperature difference into electricity. So I'm creating a brick, usual brick for building, which could be used to generate electricity. And the thing is that so it's basically making a thermogalvanic cell. That's what it's being called. And basically, it's a cell that converts temperature difference into energy, right? So I'm making a thermogalvanic cell, a brick, which is also a thermogalvanic cell. But the thing is that if you make that whole brick as a thermogalvanic cell, you have certain standards that you have to meet. And as scientists, we know that you have to adhere to certain standards, even as we come up with solutions. You don't just jump into coming up with solutions. So there are certain standards that you have to adhere to. One of the standards is ASTM standards. And with that, it also deals with compression strength of the brick, right? Compression strength of the brick. And so that the brick will be able to withstand certain loads in building. So the advantage of 3D printing in that is that what I have here is called a Schwartz D structure. Yeah. So we have the D means diamond. So we have Schwartz D, we have Schwartz P, and we have gyro. They are all minimal surface structures, and the amazing thing about minimal surface structures is that you use the least amount of material to give you the best amount of strength that you need, right? So think about lattice structures, right? Think about parts, machining parts for making parts for even space exploration. So you need to reduce the weight so you could use less amount of fuel, right? And all that. So you need that amount, but you still, you don't want to compromise on that strength, right? So that's a good advantage of minimal surface structures. So I'm using the Schwartz D to be able to still give that compressive strength. So you could see that, I'll be passing this around. You could see that it's hollow, but it also, which means that it does not prevent the movement of ions from one electrode to the other, but it also makes you good use of the compressive strength, high compressive strength of the trustee structure. And amazingly, with 3D, before 3D printing, it was just an equation. So it's a mathematical equation, right? Before 3D printing, it was just being stared at, seeing that, whoa, that's an amazing thing, that's an amazing structure, but we can't make it. You can use, it might be difficult, I don't know, but you can use maybe CNC to make structures like this, right? So, let me pass it on.
Thank you.
So, yeah, so with that, before 3D printing, you couldn't make it. So now you could 3D print structures like that, and you could use them in whatever research that you're doing. And the amazing thing is that with the resource here in ASU to make a space, the filaments are free, right? How cool is that? How cool is that? Yeah. So you just come in there, have your model that you want to 3D print and print them. So with this, I've printed that is in. There's a filament by Zotrax called Ultra. It's basically a high, a more durable form of ABS. ABS is another form of plastic, right? So you could print in ABS, you could print in PL. There are different forms of plastic that you could print in. And I also have that in a different form of plastic, which is a combination of polycarbonate and carbon fiber, right? All to test the different strength and different properties of the structure in the brick. So that's an amazing project that you could, one advantage of 3D printing. I told you I'm 3D printing. So yeah, that's an amazing thing. One thing about the 3D printers. Another project that we are working on is I'm trying to 3D print the campus, ASU campus. So now you could generate STL files. STL files are the language that the CAD design is speaking, right? So you could generate STL files where you could generate STL files of different maps, right? So you have a geographical area that you want to 3D print, right? You want to see the model of. So you could just select that geographical area. There are numerous of softwares nowadays. Yeah, so you could select that geographical area, and you'll get the STL file, but you have to do a lot of improvements to the STL file so that you can be able to print it. Yeah, so that's one thing that we are working on, and we have a basic form there, like a small prototype there, but we're planning to make it bigger and probably have it in all the other libraries. Yeah, and it could be an amazing way to just see how the campus is, and maybe you could have a 3D map, right? 3D printed map, an amazing way to have 3D printed map. Yeah, in that way, it would be really, really hard to get missing on campus. Yeah. So basically, those are some of the projects that we are working on. There are other advantages of 3D printers, and being citizen sciences, there are certain equipment that we might use, or tools that we might use, that you have to even 3D print, right? Maybe you're waiting for a kit and it's not getting in. And if you can design it, and I always have this saying, if you can think it, you can design it, and you can make it, right? Especially with 3D printers, it's really, really amazing and awesome. Yeah. So as being citizen science as well, we could generate our own tools to be able to help us be able to make our research that we want to do, and it's really amazing. Thank you. Yeah.
You have sort of training for people who want to be able to access that kind of resource but not go anywhere.
Sure. Yeah, we do. So we have workshops over in the makerspace, and so every month we organize workshops, and some of the workshops they vary across the equipment that we have there, from how to do CAD modeling to how to use the equipment in there, right? So we do have workshops. So you just have to go to our website. You go to the ASU website, the library website, and you could find the makerspace link over there, and you could sign up for to use an equipment, and you could also sign up for the programs that we have. Yeah, so we do have trainings.
And also, after Sahas is going to talk about some of this work, but then there's going to be a chance to go see both the studio and the makerspace. So
I just had one other question. What's the most unusual thing that somebody thought of and then came in and wanted to 3D print?
Yeah. Okay. So this is amazing. There was this professor who, to me, maybe to Victor and Shaha, there are different things that you've seen. Yeah. Yeah, because people really come there with different stuff. So with me, one time a professor came in, and she was working on a project where so it was a big project where they noticed that the corals in the seas are being deteriorated. So small fishes couldn't hide any longer from the larger ones, right? So they wanted to replace those corals with like artificial corals. So they wanted to prototype certain corals so they could help in that, right? So probably not looking at putting different plastics also in the water, but you're trying to use different other materials like maybe cement and I don't know, ceramics. Yeah, ceramics. Yeah, that was what they were doing. So yeah, so she came in and wanted to 3D print some corals, but she didn't know the software to use. So we helped her out by figuring out a software which is easy to use easily to make corals. And depending on what you want to do, there are easy softwares to help you do that. And with that, we used Sculptress, which is an amazing, also an amazing CAD software. So Sculptress is just like having a piece of clay and just pulling and dragging and mold and kind of like actual mold. So with that, it was easy to make a sculpture, to make a coral, and you could mirror some of the features that you make and all that. So we ended up making a prototype for her, for her to see how amazing it would be. And with that, with an STL file, you could actually put in. And currently, we have 3D printers that print ceramic, right? The printed clay that you could heat up and print ceramic. So with that STL file, you directly put it in the 3D printer and make those kind of like corals.
Very cool. Thank you.
Any other questions? Okay. Thank you.
Ross, do you want to connect that to the so long ends. There we go. There you go. Yeah, all this can be over. That work?
My name is Shaha. I work with Victor in the makerspace. I'm a born maker, basically. Like I was making since I was 5, so I just love making stuff. I've been making like a lot of stuff. I've made my e-bikes, made a few other projects like a mountain board that I use on campus. I don't know if you guys see me riding like one of those massive boards. That's me. I made a chute which like could report your location so that you can track missing children. So all of that just like revolves around me loving to make stuff, and I'm like happy when it like has a purpose, like when my projects have a purpose. So that's a little bit about me. I'm working on a unicycle currently. It's like to show what a makerspace can do. So like we come from all different backgrounds in the makerspace. And this project here, we're talking about like real companies starting. So like this product is chemical engineering, computer science, like electrical stuff, and like everything you can think about in one product. Like there's like 5,000 things you have to think about when you make a product. Like there's certain things you can't make aluminum to do, which you have to like find your way around. Like it's just like amazing what a makerspace can do. And like the one we have at Hayden, like we have electronic station, we have 3D printing, we have like sticker making, the one I made here. I don't know if you guys can see, but Yeah, just to like speak about what we have, more than what we have like a resource of people in this space. Like Victor's like super pumped about projects, like he's an awesome person, like he lets us work on our projects at the job. We have Ben, we have Matt, he works in the studio. Like, so like how this relates to citizen science is like everyone can get into the making without even like worrying about being an engineer. Like you don't have to be a PhD to start making stuff and create a difference. So talking a little bit about my unicycle, this is the model I'm trying to make in Fusion 360. This is like, it's gonna be a one wheel that you balance yourself on and you just ride it like wherever you want. And the way this works is like, have you guys tried ever balancing a broom on your hand? Like a broomstick on your hand, you know how that works? So you like kind of like move your hand to maintain the balance. That's exactly what this is gonna do. It's gonna be, it's called an inverted pendulum. I'm not gonna go into the physics of it, but like I'm just gonna tell you like how it works. So like there's a pivot, this thing is a pivot, right? That's an axle. You stand on it and it balances you like a broom, measuring your angle from the vertical. That makes sense. Does that make sense? So that's the unicycle. The benefits of this is gonna be like how portable this is. Like think about carrying a suitcase, which is a vehicle for you. So like you can just hop onto it and just go. So that's the project. This like I just love making stuff, so I make it. But it makes me happy when like it serves a purpose to someone else. So that's me. Show my video on this. If you have time. Yeah.
So you guys will see that wheel moving over to the makerspace. But that was totally created by Shaha, that CAD model. And I'm pretty impressed with how it looks like.
This is the board that I made in the summer. Because I don't have a car to drive, I created my own modes of transport, and that is like a massive, like a 4-foot long, 10-inch wheel board. It's really fun to ride. It's like ridiculous. Like people like when I pass by them, they're like, "That is amazing." So like it feels good to like just ride along. I'll show you the video. It just shows how it works and like what's inside of the board. If you have the audio, it's just music. If not, it's not.
You can hear it a little bit.
Well, it's coming out of his laptop, so where's your? Oh no, it is coming out of the laptop. It's just not very loud.
And this video was filmed in the studio. Just good to know.
Whatever you do, don't push that red button.
The skateboard is controlled with that little motor that we've got.
It actually steers
And they can
too.
go back in time.
And you made all of that in the makerspace, basically.
Yeah, it was like all made in the makerspace. If you see, like Ben was talking about 3D printing, and he was asking like, what's the most unusual thing? Like the unusual thing for me is like my own project. Let me show you what I mean. So this piece here, can you see this? This piece was printed in ABS, and it's taken like rough terrain. So like that's what like an application of 3D printing can do. Like it's broken sometimes, and I have had hard times like dragging that thing back home. But like now, I redefined the structure and like made some changes, and it like lasts long. So that's one of the unusual projects like we could do in the makerspace just because we had access to a 3D printer. Yeah, that are my projects.
Very cool.
Not yet. Do you think there's a value to it, or does it make a case again? So because sanitation is absolutely. I do see a value of people bringing it. Using makerspace as a lab. I mean, I'm seeing that throughout, like the brick that Obeng is working on is something that is actually help a lot of areas. So it's like sort of a scientific thing that like could be thought of like that, where people have an idea, they go to a makerspace and they get it done. Prototype idea. Where I see a really good connection, and I'll just go to the front, where I see a really good connection. The makerspaces and citizen science is the fact that, like, I'm seeing people all of the time in my space work out problems and figure out resolutions to situations, whether it's helping the world from plastic or like, so trying to figure out, ways to be sustainable, to people who are just trying to teach anatomy, to younger people and get them inspired to get into science at a very young age, so that they can start critically at a young age, so that they have that mindset once they get a little bit older to get into science and that. Where I see maker spaces, and not just our maker space, being really valuable to citizen science is, there are going to be as many ideas as there are people, really good ideas that can collect really good data for us to know more about ourselves and the place that we live. Maker spaces will allow people to be able to prototype and work on those kits, right? So when you have an idea for a kit, there's going to be some prototyping that's involved in making that kit. And so maker spaces are going to be a good spot just because they have the tools, right? You were asked earlier on if we have training on the tools in the shop. We do have workshops, but I would not just limit myself to the workshops. If you want to learn about 3D printing, sign yourself up for a 3D printing consultation and come down and learn how to 3D print. So you can go to our website. Our website is lib.asu.edu/MKR. And you can sign up for yourself for a consultation from Arduino, so like computer programming, if you want to do some of that stuff, to sewing, to 3D printing, to working in the studio, making your own podcast. So we have a staff that's trained. They do have specialties. So sometimes if you want like in-depth training, I will set you up with the person who has that specialty. But we're here to assist really good ideas, right? A lot of good ideas die, never, ever, ever, get made. And I think that giving access to as many people as we can to the facilities and the training to get those ideas, not to die, to make them live, you know, our lives will be better, I think. I really like citizen science because, you know, most of the time the projects that are you know, in that situation are trying to make, you know, our world a better place. It's a really good thing to be a part of, like Sahas was saying, you know. So helping out people that are coming into the makerspace is what we love to do, because people are coming into the space with really good ideas, and we're trying our best to help them get those made. And so if you ever have a project like making a restroom, you know, and figuring that out, I might not have all of the equipment in my space, but what I really appreciate about citizen science that makerspaces don't really have is this sense of community. And that's something that we can both help one another out with, right? So makerspaces, the culture of a makerspace, the opportunities that a makerspace gives a community, those are things that are really not, they're just being discovered right now. The case studies are being made for makerspaces. And in another 5-10 years, I know that for a fact, there are going to be like some really amazing things that are going to exist in this world, and you're going to talk to that scientist or that person, that citizen, and they're going to say the reason that this was made is because I had a makerspace in my community. So so makerspaces, not only just makerspaces, but makerspaces specifically in libraries, is another, I think, really good connection that citizen science can be making, because libraries, they're at the center of a community. They're concerned about social justice issues. They have people showing up at libraries to do research to make the community a better place. To have a makerspace in a library is something that's happening more and more often, and that is because it's just a perfect marriage. And so I'd like to give you all a tour. I'll answer some questions, but then I'm going to give you a tour. I'm going to show you, we have 2 rooms that I'd like to show you here at Hayden. And these are temporary spaces. So these are here for about a year, and that's not a bad thing. And about a little bit more than a year, we're going to take over a really big portion of the 3rd floor of the new Hayden Stacks. And at that time, we will have laser cutters. We will have 3D printers, proposing 3D printers that you can actually even borrow. So not just the makerspace and what the tools that are in the makerspace. In the near future, we will be extending our tech lending program, which we already have now. You might not know about it, but we have laptop chargers and calculators and all kinds of earphones, all kinds of things that we lend out as far as our tech lending program goes. We are going to really expand that. So there's a proposal for us where you can come in and borrow HD camera and go out and do filming. You can borrow a DSLR camera, a 360 camera. You can borrow 3D scanners. It's the direction that libraries are going in, especially research libraries. So. Any questions? Okay, cool. Let's take a tour.
Yeah. Darlene, are you still there? No?
Yeah, I'm here. I'm
Okay.
listening. I'm sorry, I'm on mute.
No worries. Do you have any questions? We're going to go tour the spaces and probably hang up and stop recording.
No, I think that was helpful, and it would be good, and it's good that Dan's in there too, because Dan, maybe if you haven't already connected some of the dots with the last speaker about some of the work that we're doing with public libraries and citizen science, that would be great.
Okay. So, cool. And a recording of this will be up and out in the email, Darlene, if you want to see what people were showing.
Great.
While they were talking. So
that sounds good.
I'll talk to you
fun
later.
on the tour. Bye, everybody. Have a great weekend. Happy Thanksgiving.
Yeah, you too.